Hello everyone. We have a question which says that a block of mass 15 kg, which is over here, hangs in equilibrium. So the condition is an equilibrium condition and it is hanging below a horizontal ceiling. This is a horizontal ceiling. It is hanging below, attached to two strings, and definitely the two strings are this one and this one as shown in the diagram. Very clear statement. One of the string is inclined at 45 degree to the horizontal. Yes, it is 45 degree to the horizontal, and the tension in this string is 120 Newton. Yes, it is mentioned over there. The other string is inclined at an angle of theta degree to the horizontal. Yes, theta degree to the horizontal, and the tension in the string is T Newton. It is mentioned in the diagram. Find the value of T and theta. So basically we have to find the value of this T and theta, and the condition that they have given us is an equilibrium condition. And when it comes to equilibrium, we know that equilibrium means opposite forces are equal. And when we say opposite forces are equal, that means the opposite horizontal forces are equal as well as the opposite vertical forces are equal. For that, we have to split up the diagram into horizontal and vertical component. But before that, we have to understand what the horizontal and vertical components are. If you just look at this diagram, that I have drawn two right angle triangle representing the force F, and the position of the angle theta is different. I have seen that most of the students have a misconception that the horizontal side is always a cos component of the particular force. No, it is not like that. If this is an angle theta which is given in the diagram, then the side next to that would be a cos component of that particular force, and the opposite would be a sine component of that particular force. But if the angle given in the diagram is over here, then the side next to that would be a cos component, and the opposite would be a sine component of that particular force. So it depends upon the angle, where the angle is. Based on that, we will decide which one is the cos component and which one is the sine component. I have splitted up the diagram into horizontal and vertical component because the weight was 15 kg of this particular block, and if I multiply it by 10, it would be 115 Newton, because all the forces are in Newton. So we have to convert this mass, which is in kilogram, into Newton, and we know that weight is equals to mg. M is 15 and g is 10, so definitely weight would be in Newton, which is 115. So if we just look at this 120 Newton force over here making an angle of 45 degree and splitting up into component, the angle is with this horizontal, so that would be 120 and cos 45, and this vertical would be 120 sine 45 degree. Similarly, this T Newton force is over here. It is making an angle theta with the horizontal. So this side would be T cos theta and this vertical side would be T sine theta. In the question, they have given us a condition of equilibrium, and definitely, as I have said before, equilibrium means opposite forces are equal for horizontal as well as vertical. So first of all, just look at the horizontal forces and then we would work out the vertical forces. If you look at the diagram, the horizontal forces, we have 120 cos 45, which is to the left, and T cos theta to the right. Because the condition is an equilibrium, that means 120 cos 45 would be equal to T cos theta. So 120 cos 45 would be equal to T cos theta. So finding the value of 120 cos 45, which is 84.85, equal to T cos theta, this is our equation 1. Similarly, we would create another equation based on vertical forces. We have two forces pointing upward, which is 120 sine 45 and t sine theta. Just add both of them because the condition is an equilibrium. So the sum of these two, which are pointing upward, would be equal to 150, which is downward. So from here, just get the value of this 120 sine 45, move it on the other side, subtract it from 150. We have 65.15, which is the t sine theta. Now we have two equations in the form of t cos theta and t sine theta, and definitely our target is to find the value of t and theta. So we have two different methods to work on that. Both the methods are super simple. So the first method is dividing the equation 2 by equation 1. That means t sine theta divided by t cos theta over here is equal to 65.15 divided by 84.85. Cancelling the t, and then sine theta upon cos theta is tan theta. After dividing 65 divided by 84 would be 0.7678. Taking the tan inverse of this, and the angle theta is 37.5, which is the requirement of the question. Now placing this value of angle theta in any one equation, whether equation 1 or 2, if we take equation 1, which is t cos theta is equals to 84.85, placing this value of theta over here with cos, dividing it by 84.85, and finally the value of t is 107 Newton. Very easy method. We do have another method also, which is also very simple, that is squaring and adding equation 1 and 2. That means first of all you have to square the equation 1 and 2, and then you have to add. Equation 1 is t cos theta, equation 2 is t sine theta. Just first of all square them and then add them, and definitely that would be equal to 84.85. Square them, 65.15, square them, and then add them. After simplification we have this value, which is 11,444, and after opening up the bracket we have t square cos square theta plus t square sine square theta. Taking t square as common, in the bracket we have cos square theta plus sine square theta, which is an identity equal to 1. So we are just left with t square equal to 11,444. Taking the square root, we have the same value of t, 107 Newton, which we found from the method 1. Placing this value of t in any of the equation 1 or 2, if we take equation 1, which is t cos theta is equals to 84.85, place this value of t over here, divide it and take the cos inverse of it, and the angle is 37.5, which is the same. Both the methods are super simple. It is totally up to you which method you have to use.